4.3 is going to be talking about the formula for finding areas of trapezoids. And if you were in class with us when we did the activity from RapJ on page 85, then you probably already remember that we were able to figure out that a trapezoid, if you cut it apart at one particular spot, will always be able to turn into a triangle. So we actually end up using something that's very similar to that triangle formula, which is normally area equals 1/2 times base times height. But in a trapezoid, where there's not just one base or one height, you have to remember to use both of your bases and add them together before you can use that formula. But otherwise, you'll notice it's very, very much like that triangle formula. So in area of a trapezoid, you take 1/2 times both bases added together, base 1 plus base 2, times the height. And then just again, for your benefit, sometimes, because people worry about not seeing that height on the outside of the parentheses, sometimes they will move it to the beginning and they'll take half of the height and then multiply it by the two bases added together. So it's the same either way, and you might see it both ways. And again, when we find the area of the trapezoid, we're starting by putting the formula down first. So the area of a trapezoid is 1/2 times base 1 plus base 2 times the height. And then we're just going to start filling those things in. So area is still going to be equal to 1/2, but our bases are going to be 9 and 5, so we'll add them together. And because of those properties we've talked about, doesn't really matter which one is base 1 and base 2. It's fine if you move them, because 9 plus 5 is the same thing as 5 plus 9. And then multiply that by the height, which, don't forget, is going to be on the outside. It's going to make that right angle. In this case, it's 6. And when we add our two bases together, we get area is equal to 1/2 times 14 times 6. And again, we have those same choices we did when we did triangles. We can multiply 14 times 6 and then divide that product in half, or we can divide half of 14 right now, or half of 6. We just can't do half of both. And I'm going to take 14 and cut it in half just because it's the bigger of the two. So if I do that first, then area is going to be equal to 7 times 6, because I have to leave the 6 hole, and then area would be equal to, for my final answer, 42, and I check my label, it looks like it's in feet, so that's going to be feet squared for my final area. For letter B, we're going to do the same thing. The only difference this time is we've got a few decimals involved. So formula is area equals 1/2 times base 1 plus base 2 times the height. And when we fill it in, we've got, again, either base can be base 1 or base 2, doesn't really matter, but 11.5 is one of them, 8.5 is the other one, and then my height here is times 5 meters. And you'll notice you can either choose to put that in parentheses, or anything right next to parentheses without any symbol in between automatically means multiplication, so either way is fine. And then when we go to the next step, we've got 1/2. Again, but we have to make sure that we do our correct addition. So if you needed to do side math, make sure you line up by place value, and don't accidentally put them just lined up to the right. In this case, it works out, but we go ahead and add them and drop our decimal straight down, which we've got 20 times 5. And again, we can choose to cut one of them in half, or we can choose to multiply and then cut in half. I like the idea of cutting that one in half, so I'm going to do half of 20, which is 10 times 5. So area would be equal to 50, and in this case, it's meters squared. For example 2, we're going to find the area of a trapezoid on a grid, meaning they didn't give us the dimensions. We're going to have to figure them out by counting and things like that. So in this case, we have, again, we have to decide what's the base and the height, and so it could be that these would be the bases, but if I were to try to pick those, I can see I'm not going to be able to make a 90-degree angle with either of those sets, so that must mean that my bases are on the sides this time. So I'm going to go ahead and label this one over here as base 1, and this one over here is base 2, and again, it doesn't matter which is which, but then that would mean that my height would either be on the inside or the outside, doesn't really matter, but I would have to create that 90-degree angle there, and so then this one would be my height. And then to be able to find the area, I just have to figure out my dimensions. So when I'm looking here, my actual original shape, it looks like base 1 is 2 units because it's 1, 2. So I'm going to label base 1 is equal to 2 units. And then over here, base 2 is only one box all the way across there. So base 2 is only equal to 1 unit. And then my height, I've got 1 box, 2, 3, 4, 5, 6 boxes, so my height is equal to 6 units, and then I would go ahead and use my formula, which would be 1/2 times base 1 plus base 2 times the height. I would fill in with my 2 bases. Doesn't really matter again which is which or what order you put them in, as long as you've got the 2 bases there and the height on the outside. And then I would add my bases together, keep that height multiplied. I'm going to choose to divide that one in half this time. So, oops, since I'm cutting in half, I just need to bring the 3 down, and then half of 6 would also be 3, and then A would be equal to, or the area would be equal to 9, and since they didn't give us a specific unit, then we would just use the label units squared for this one.